Section 12.7 is on the trig ratios, the basic sine, cosine, and tangent ratios. We're going to use the sine, cosine, and tangent ratios in order to relate the lengths of the sides with the angles. In the previous sections, we learned about the Pythagorean theorem, a squared plus b squared equals c squared, that relates the lengths of the sides of a right triangle. And trigonometry allows us to relate the lengths of the sides to an angle. So our three different functions are going to be the sine function, cosine function, and the tangent function. And so the sine is opposite over hypotenuse, that's the ratio. The cosine ratio is adjacent over hypotenuse, and the tangent ratio is the opposite over the adjacent. And so we're going to use these and our calculators in order to find the lengths of some sides. So we use our mnemonic device SOHCAHTOA. SOHCAHTOA is the way we're going to remember our trig functions. So is the sine is equal to opposite over hypotenuse. Ka is the cosine is adjacent over the hypotenuse, and toa is the opposite over the adjacent. So SOHCAHTOA is our way of our mnemonic device that we're going to use to remember the trig functions. Our trig ratios can be set up by taking a look at a triangle, which we're going to name triangle ABC. So the angles are going to have a big letter, capital letter, and the opposite sides are going to have a lowercase letter. And the reason we do that with the same letters is the opposite side goes with the angle. So if we're going to say, hey, what is the sine ratio for angle A? So what is the sine of angle A? Well, the sine is opposite over hypotenuse, and the side opposite the angle A is side A, and the hypotenuse is C. So what is the cosine of angle A? Well, cosine is going to be the ka, or the adjacent over the hypotenuse. So B is the adjacent side. Now, when you look at angle A, some students say, hey, isn't C also adjacent to angle A? Well, it is, but it's the hypotenuse. So B is actually the adjacent side, and C is the hypotenuse. And then the tangent of angle A is equal to the opposite side, which is A, over the adjacent side, which is B. So that's looking at those trig functions using angle A. We can also look at them using angle B. So you'll see how these ratios are going to change a little bit, because the opposite side of B from angle A is this length B. So that's why B over C is now the sine ratio for angle B. The sine ratio for angle A and the sine ratio for angle B are going to be different, just like the cosine for A and B are going to be different. The cosine of B is going to be the adjacent side, which is side A, over the hypotenuse, which is side C. And the tangent for angle B is going to be the opposite side B over the adjacent side A.